This is week 10, and this is day 18, and I'm also including day 19, which is Friday. Intro to Computers talk about the network layer and routing, in which then IP addressing. Packet tracer 6, need to do that on campus, or you need to be using packet tracer 7.1 version, which is a little bit older version. And students should be working on curriculum and doing the quizzes on a regular basis. We covered network access, data link, and the physical layer. How do we get access in? Okay, from all of our N devices. Alright. And talk a little bit about the transport layer, TCP, UDP, and the network layer. Okay. This is where we resend packets, or we stream packets through. We don't resend them. The network layer, IP and path, connectionless, best effort delivery, media independent. Logical link control down below connected into this layer. MAC addresses connected to the physical layer, if you want to think of it that way. But the key here, connectionless, doesn't care about where it's connected to. Best effort doesn't check if the packets get there, and doesn't care what we're sending across. It's just worried about the best path. Okay. That's important. The slides got mixed up here a little bit, but we're going to run with this anyway. You should know the difference between public and private addresses now, or beginning to realize that. These are private addresses right here. We have a group of them with 10s. We have a group here 172, and we have 192, 168. In old time, this was a Class A, this was a Class B, and this was a Class C address. Okay? Don't need to worry about that now. So, we use the example of private addresses. You can assign them static. You can set it static, or it can be dynamic, DHCP. Then that private address is converted to a public, or sometimes called a global address that can be used on the internet. So, this slide should have came before the other one. So I'll reiterate. You should understand what these things mean. Connection, best effort, connectionless, best effort, media independent. Okay, I just mentioned these two on the other screen, right? We have the network access layer, in which the MAC address, right? These two make up the data link layer. The MAC address then is used to connect to some device like a switch, right? The logical link control connects us into the network layer. These layers, they don't, all they know is the data link layer gets data from the top and sends it down here, physical layer, then eventually it puts it on the wire, and on the other end, if we were to use another color, comes off the wire, physical layer passes up the data link layer, strips off the MAC addresses, passes it up the IP layer, looks at the IP addressing. If it belongs to this computer, checks the transport layer. If it's TCP, it's going to check the sequence number, and start putting them in order, and then eventually send it up to the app. Friday. Oh, here. I usually do it in yellow. Friday. So this is still week 10, and this is day 19? Yeah, this is day 19. Alright. We're going to take a look at IP addressing. Just touch upon IP6, lab work. Next week, IP6 and subnetting. Yeah, we start subnetting here pretty quick. So, we have a couple different diagrams of this. So we have 4 routers and 4 switches, and we are in groups connecting to these. Okay, the groups configured the switch and the router connects up here to this multi-layered switch. So these are all routing ports from the router. So they all have to have IP addresses. That makes sense? Just like these ports all have to have IP addresses. They're router ports. Okay. Then we connect to this router, which does NAT, and it sends it into our network, which in this case we're going to 172.20, in fact 00/16. That's going to make more and more sense as we move along. Talk a little bit about the computers out here. They do an ARP, and if they can't find the computer they're looking for on their current network, then they do another ARP to the default gateway. And that ARP, that gives them a, I'll just in red, gives them a MAC address to go to, and that MAC address is up here at the router. So then the information goes up here. And then it starts getting routed. Okay? If it's going all the way to the internet or going to another network over here. So we talked about ARPs are broadcast. So in a router, when you separate these networks, you got one here and one here. When this one does an ARP, the router does not forward a broadcast. So that broadcast stays within this particular network. Same thing over here. When this does an ARP, that broadcast stays within that network. So it doesn't affect the computers over here. Handing is a process where you take the router takes the IP address of where it's going and the mask, and it ANDs that, and then what it gets out of that is the network part of the address, and then that's used in the routing table. We've gone over that before. I'm not going to repeat it again. Bandwidth, bits, how many bits per second, or sometimes written like this, bits per second. A unicast is a good example of how the web works. You could be somewheres, and if you're contacting a web server from this location, that's a unicast. A broadcast goes to everyone, and a multicast goes to just a selected group. So routers can take a packet and send it and send it and send it, and then not until they absolutely have to, they can split it up so it goes to a couple different locations. Again, here was just talking about converting bits to hexadecimal or decimal, or from decimal to bits. We had them ping, network, host. 24 prefix bits, so that's 888, so that's the network part. Same thing down here. The network part, that's a /24, this part's the network, and the other part's a host. If it's a 0, it's talking about the network. In this case, if it's 255, it's talking about the broadcast. So you would never have that assigned to an interface. You would never have a 0 or 255 in this case. Okay. Here's an example of NAT. We looked at one of these before. I'm way up here at the top. So this is the inside global address. So that's the one it's converting to. This is the inside local address.